Welcome to this comprehensive technical guide on advanced air conditioning solutions using liquid desiccant technology. We will explore its principles, applications, standards, compliance, and how it redefines energy efficiency. On behalf of Cesar Serrano, who has 30 years of experience in the air conditioning segment, the content of this presentation is divided into 6 parts. The first one focuses on desiccant liquid technology. This type of technology has won 2 innovation awards. In 2023 was a finalist for air conditioning applications at the Air Conditioning, Heating and Refrigeration Expo. And in 2024 was the winner in the refrigeration segment. In general terms, the desiccant liquid is one that cools and absorbs moisture from the air. The system is composed of a conditioner and a regenerator. The conditioner, what it does is to cool the desiccant liquid and makes it pass through a medium where it comes into contact with the air. This is a very efficient way to condition the air. The blue box shows the component known as the conditioner. The red box shows the component known as the regenerator, and the black arrows indicate the flow, how the desiccant liquid circulates in the medium, and it is in that medium where the desiccant liquid has contact with the air. As I said, the conditioner, which is at the top, what it does is to cool the desiccant liquid, makes it pass through a medium which is in the center, where the black arrows cross, and the red box shows the component known as the regenerator. Let's go over the process again. As I was saying, the conditioner, which is the top part, cools the desiccant liquid and makes it pass through a medium, which is the one in the center where the black arrows cross, and that medium is where it comes into contact with the air, is where the water vapor that contains the air condenses and cools at the same time, which is a very efficient way to condition the air. The liquid then arrives to a container already as a mixture, which is the one in the upper part of the red box. This mixture includes 2 components. One part is the water condensate, and another part is the desiccant liquid. This mixture is pumped to a regenerator, which heats the mixture in order to separate the condensate from the desiccant liquid. This already separated returns to the conditioner to be cooled again and continue with this continuous process. This is a process of cooling, dehumidification, and condensate separation. What this equipment needs is chilled water at 50 degrees Fahrenheit to feed the conditioner and hot water at 120 degrees Fahrenheit to feed the regenerator, a much lower temperature than the more than 170 degrees Fahrenheit that is required when working with a desiccant wheel. Unlike conventional systems, this technology directly removes moisture by contact with a liquid desiccant, avoiding overcooling or overheating, resulting in higher operating efficiency and better humidity control. In this image, you can see the 2 main components of the system, the conditioner and regenerator, which are the heart of the system. These can be installed either together or separately. The cover in the image in the lower right-hand side, with the AirGreen logo on the cabinet, can be disassembled and allows the cabinet to be joined to the regenerator cabinet so that they are operating as one piece. And also, if the available space does not allow the system to be placed in one piece, it can be separated and placed remotely. The system takes advantage of the exhaust air in order to regenerate the desiccant liquid. 50% of the applications are in process plants, food, beverage, chemical, petrochemical, and other industrial processes, where you can get a line of chilled water at 50 degrees Fahrenheit that would feed the conditioner. Likewise, you can take advantage of the waste heat of the processes with a plate heat exchanger to obtain water at 120 degrees Fahrenheit. Waste heat is abundant in process plants of this type. However, for more commercial applications, the system is connected to a simultaneous cooling and heating system, or what is known as 4-pipe chillers that provide hot and cold water simultaneously. This is not possible when using the desiccant wheel, because the system in this case requires temperatures of more than 170 degrees Fahrenheit, so in these cases a boiler is required. This graph shows a thermodynamic comparison of the three most common types of cooling or air conditioning from the point of view of temperature and humidity. First of all, by avoiding the need for extensive pre-cooling and post-cooling, liquid desiccant systems achieve precise humidity control at a fraction of the energy cost. The blue line shown in the image below represents the direct expansion and reheat cooling process, which is the one used with package or split equipment. The red line represents the relative dehumidification process in a desiccant wheel, since what it does is to heat and then cool. And finally, the most efficient thermodynamic process is the one carried out with the desiccant liquid, which is the one represented by the green color. This chapter focuses on the energy savings and performance metrics of liquid desiccant systems, illustrating their efficiency and cost-effectiveness. On the right-hand side, you will see a technical note that is classic in terms of the liquid desiccant component, and as you will see, the entire liquid desiccant pumps and all the accessories that are included in the system do not require more or consume more than 20 amps, which gives you an idea of how efficient the system is. The comparison that can be seen in the image highlights the efficiency of liquid desiccant dryers in reducing operating energy costs with regeneration temperatures as low as 110 degrees Fahrenheit. These systems drastically reduce daily costs compared to the high energy demands of solid desiccant wheels. The graph shows 5 analyses. The one on the left is for the liquid desiccant with cogeneration, in this case using electricity rates and gas costs from the U.S. Energy Information Administration. The fact that the desiccant wheel marked in orange uses higher regeneration temperatures requires more energy for the regeneration process, which is not the case with the desiccant liquid. The gray line uses a 4-pipe chiller. The yellow line uses a desiccant wheel system with a boiler, since it requires a temperature of more than 170 degrees Fahrenheit. The extreme rightmost line in blue is a direct expansion system with reheat. In general terms, the savings range from 20 to 60% depending on the system and the operating conditions, and this gives you a clear idea of the benefits of desiccant fluid. For high humidity environments, such as indoor agriculture or greenhouses, as shown in the image, liquid desiccant systems offer a double advantage: efficient climate control and sustainability. These systems adapt to changing conditions, ensuring optimal energy use. One of the advantages in this type of application is the fact that plants in this type of environment generate a large amount of latent heat. The lack of effective humidity control creates condensate on the leaves of the plant, distracting it from trying to obtain its nutrients from this condensate and thus preventing its rapid growth. On the other hand, Effective humidity control prevents condensate from being generated on the leaves of the plant, and this allows the plant to focus on the subsoil to obtain its nutrients, which allows it to grow faster. The adaptability of desiccant liquid systems extends their energy-saving potential to multiple sectors. When integrated with cogeneration systems, these solutions achieve unparalleled sustainability and operational flexibility. Now let's delve into the various applications of liquid desiccant systems and how they address specific challenges in different industries. Liquid desiccant systems excel in multiple sectors, addressing unique challenges with customized humidity management solutions. Let's explore these applications and their specific benefits. As you can see in this slide, this technology is very efficient in applications where a large amount of air volume is required to treat, such as schools and auditoriums, data centers also, and applications that generate a large amount of latent heat, such as agricultural applications, which is the first line item on the slide of. Applications that require 100% a large amount of outside air to treat as pharmaceutical manufacturing, and in the case of hospitals in some areas, where it is required to treat a large amount of outside air as well. In applications where you must have precise control of humidity, such as data centers, breweries, and food processing. When we talk about cold storage, this refers to conservation and freezing cold rooms, where this type of technology prevents the accumulation of frost, i.e., as it is injecting dry air, the evaporator of the cold room cooler does not generate the frost that would otherwise generate, so it eliminates or dramatically reduces the need for defrosting and thawing, saving energy. From farms to food processing plants, liquid desiccants offer unparalleled moisture control, ensuring quality and cost-effectiveness. One of the most important benefits in cold storage and food processing is the fact that you avoid condensation or freezing, which causes mold and mildew. By circulating dry air within these types of applications, you also avoid the additional cost of defrosting, which is what I mentioned in the previous slide. And by effectively controlling moisture, you prevent the growth of bacteria, molds, and viruses. By maintaining optimum humidity levels, liquid desiccants improve safety and comfort in hospitals, schools, and recreational facilities. Infrastructures such as data centers benefit significantly from humidity control, extending equipment life and supporting global sustainability efforts. Let's review how liquid desiccant systems meet industry standards to ensure reliability and compliance with stringent standards. Liquid desiccant systems comply with a variety of ASHRAE standards, ensuring high performance in critical areas such as energy efficiency, indoor air quality, and environmental impact. Many of these standards apply to comfort conditions and not necessarily to effective moisture removal. ASHRAE 90.1 excludes specific humidity levels, such as those required in museums and hospitals, and normally the standard tries to avoid excessive cooling and overheating. On the other hand, we exceed with this type of technology the minimums established by the SIEMR, which is Seasonal Internal Efficiency for Moisture Removal. These systems achieve a perfect balance between energy efficiency and indoor air quality, and are an excellent choice for environments with strict compliance needs. Liquid desiccant systems are designed for optimum performance, ensuring compliance with thermal comfort, sustainability, and stringent standards. In healthcare environments, precise humidity control is critical, and these systems ensure compliance with stringent ASHRAE standards while protecting the health and comfort of patients. In this chapter, we will explore design considerations and maintenance protocols that ensure the longevity and optimal performance of liquid desiccant systems. Complying with a rigorous maintenance program and taking into account the design considerations guarantees that the system will operate optimally throughout its useful life. No in-depth training is required to perform maintenance on this equipment. As you can see, it is a simple system with a basic pumping system that recirculates the liquid desiccant within the system and the media, which is the cassette shown at the bottom, that generates the thermal exchange between the desiccant liquid and the circulating humid air. The maintenance requirements are really simple. Evaluation of the concentrate and does not require and does not have a lot of moving parts. Thank you for exploring this transformative air conditioning technology. Let's open a space for questions and comments on how you can apply this solution to your projects. Thank you for your attention and participation in this session. Liquid desiccant technology represents a breakthrough towards energy, efficient and sustainable air conditioning solutions. Please do not hesitate to contact us with questions or comments. Together, we can build a more sustainable future.